doubts regarding morning's class? Posture, names or anything else? So the nervous system is like the command center for your body. So major decisions will be taken and then the body will implement whatever the decisions that are taken. Okay. So this is nervous system, not CNS. So nervous system can be broadly divided into central nervous system and peripheral nervous system. The two broad, this little tabular column, you can just learn it up. CNS is further, so you have a central nervous system, central command center, and then a peripheral, because not all activities of your body require the command from your brain or from your spinal cord. And we saw in the respiration chapter also we mentioned that. Everything doesn't require your brain. It delegates also to the peripheral nervous system. Okay? So the central nervous system is divided into has two parts, the brain and the spinal cord. And the peripheral nervous system consists of all the nerves that arise from the brain. Okay? Now, the basic structure of your nervous system is the nerve cell. Okay? If you look at it at a microscopic level, now if you look at the brain, which is a part of your nervous system, what is the brain made up of? Billions of nerves. A nerve is a single cell. Okay? So, and billions of nerves form the brain. And billions of nerves form the whole of the nervous system. So the basic structure of your nervous system is the neuron. The nerve cell is also called the neuron. Now neuron is the only cell in the body which cannot regenerate once it gets damaged. Okay? Your skin cell or any other cell of the body, if you get a cut in the skin, it will grow back. If your muscle gets a tear, it will regenerate. Bones also will regenerate. If your bone breaks, it can come back together. The bone cells will form. But neuron is the only cell. Now, cell is the only one which, if it gets cut, it will not grow again. Okay? So that is. Billions of them. You have billions of them, but each one is so important. Okay? So usually, if you get an injury in the brain or in the neck or anywhere around the neck, it could lead to paralysis or various, disabilities.
If the injury occurs, will it occur to a group of neurons? Or
it could, yeah, because if it occurs in the neck, the nerves in the neck area will get affected. So you could have a paralysis in that area. So it will usually occur to a group because the neuron, the nerve cell is a microscopic cell. So definitely a group of cells will get affected. Okay? And this is how a single nerve cell is. So this is the main, like the cell body of the nerve cell or the neuron. And from it you have a long thread-like structure called the axon. And it ends in axon endings, and this is where it will connect to a muscle fiber. It can cause a muscle twitch, or it will connect to another nerve cell. So this is the main cell body, the main part of the nerve cell, and this long extension is called the axon. Okay, so the nerve impulses get conducted through the axon. And how do messages move? So basically, nerve cells they communicate with each other through electrical impulses. Okay, so that's how a message is transmitted from the brain or from the spinal cord to give the command for your hand to lift or for you to laugh, or for you to open your mouth to eat, or for you to do an exercise. Okay, so this is how nerve cells connect with each other and they transmit messages in the form of electrical impulses. So this part of the cell is called, so this is the cell body, this is the nucleus of the nerve cell. Okay, and then this long structure is called the axon. And the axon is covered by a protective layer called the myelin sheath. So this is your basic structure of the neuron or the nerve cell. Now just read this. The basic structure and functional unit of the nervous system is a nerve cell or a neuron. A nerve cell or neuron consists of three main parts. So this main part, this round part, is called the cyton. Okay, it's not there with that. Okay. Is there?
Diagram is there.
Diagram is there.
58 pages of this page. 58.
Correct. So that round thing which you see, no, the main cell body we call it, that is called the cyton. And from the cyton, that long structure is called the axon. The axon is covered by a protective layer called the myelin sheath. And you see how the axon ends, it connects with the muscle fiber. At the termination of the nerve cell, you have the muscle fiber. So that's how the signal is sent to the muscle to perform a certain function, like contraction or relaxation.
How long is an axon?
It can be very long, very, very long. Like you have your sciatic nerve, I think it is the longest nerve in the body. Starts from the lower back, from the lumbar. The axon will go all the way down to your big toe, little toe. So imagine from the lumbar spine, cell body, and then the axon will go. So
This is a single cell.
Single cell. It will go all the way down to your little toe. And the sciatic nerve is thick. You can actually see it when you dissect the human body. It's very thick. Yeah. I don't ask you too many complicated questions here.
So if the nerve is very big, is it the axon that is big or the cyton also?
No, the cyton will be also big in size, but the axon will be very long. Axon will be very long. It will be like a thick tendon. Sometimes we can confuse it for a tendon.
So, the existing group, muscle fiber, is that like a group of cells?
Yes, that also we will come to that. I'll tell you how first the nerves are grouped. Okay? So that also we will be seeing in detail in muscular system chapter. Okay? So the basic structure is the nerve cell or the neuron. And the neuron, the parts of the neuron are the three main parts, the cyton, the axon and the dendrites. You can see where the dendrites are, right? You can see that picture. Then nerve cells, several nerve cells, they will join end to end to form nerve fibers. Okay? So if you come close and see, just come up close, various nerve cells will join to form a bundle called a nerve fiber. Okay? A number of nerve fibers, the axon part of the nerve fibers are bundled together in a sheath, tubular sheath, forming a nerve. So nerve is different from nerve cell. A nerve consists of bundles of axons of nerve cells. They are grouped together to form a nerve. A nerve is actually bundles of nerve cells. Okay? And a nerve cell or a neuron is a single cell. Whereas a nerve is a group of axons of nerve cells. Okay? And in the single nerve cell, that picture on page 58, I told you the axon is covered by a myelin sheath. Myelin sheath over the axon acts as an insulator. You can think of your neurons and nerve cells as electric cables. So they will have to have an insulator and prevents mixing of impulses in adjacent nerve fibers. Simple. Okay, So we are coming back to the division of the how to divide the nervous system. So Anita, I was just telling them nervous system is divided into CNS and PNS. Central nervous system, peripheral nervous system. Okay. Now central nervous system consists of your brain and spinal cord. Now if you schematic diagram of brain and spinal cord would be just like this. If you look at your brain and spinal cord from posteriorly. Posteriorly means back side. This is exactly how it would look. If you look at it from your back. What is this one? That is the spinal cord. Yes. So that is also there in page 54.
If they are connected, why are they divided as two categories?
Because this will divide into various nerves which will supply different parts of the body. This is the brain is like your main command center. The brain has much more important functions which the spinal cord cannot do. The brain can reason, analyze, compare, contrast, make decisions which the spinal cord cannot do. Spinal cord is more of motor functions. Okay, movement, coordination, those kinds of
Reflex action.
Huh?
Reflex action.
Actions, more
Is
of
your
that.
response to stimuli usually by a spinal cord?
Yeah. Spinal cord or not so much of spinal cord but more of peripheral nervous system. It is not, doesn't require the central nervous system that much. But yeah, there is a bit of spinal cord work going on there also. Okay. Under peripheral nervous system, you have two broad subdivisions, voluntary and involuntary nervous system. Now voluntary is also called somatic. Now it will really be important and useful for you to learn these correct names rather than using the common names of voluntary and involuntary. So somatic and autonomic. And under autonomic you have any ideas? Right guesses are also welcome. Under involuntary or autonomic nervous system, you have two further subdivisions, sympathetic and parasympathetic.
So if it is involuntary for you to have parasympathetic response, then how do you control it actually?
There is an element of your own volition in this also. So that we see, that's where yoga comes in. Okay? With your yoga practices, you can control your involuntary urges or you can bring them into some level of regulation. That is the main reason why we do nervous system in yoga. Okay, it's an important aspect of study of yoga. Okay, so this is the broad thing. So all this, so CNS can only be divided into these two, PNS is all this. So you just try to memorize this or try to learn this. Okay. The brain plays a central role in the control of most body functions. So what's the function of the brain? That's exactly what I said a little earlier. Awareness. Main function of the brain is awareness. Movements, sensations, thoughts, speech, memory. So thought, speech, memory and all that, not in the spinal cord region. It's only in the brain. Okay? Brain takes in sensory information, organizes this. So another two important terms you will come across in nervous system are sensory and motor. If you go back to your middle school science, you have learned this. Sensory nerves and motor nerves. Now sensory nerves are called afferent nerves. And motor nerves are called efferent nerves. that is your reaction. So your mouth opens and then your voice box comes into play and then you give a reaction. So the reaction is called a motor, or that is performed by your motor nerves. And the sensory input, there are sensory nerves present in your eyes which take in the beautiful flower, and the response is performed by your motor nerves. So that's the sequence of events in the nervous system. The brain takes in sensory information. So sensory information, can you give me examples? Sensory nerves, your eyes, very good.
The top ear of the ear.
Yes, eyes, ears. So everywhere you have nerves, okay, which will pick up these stimuli. You listen to nice music, your nerves in the ears will pick up on those notes. And then some reaction will come out of you, right? So that is taken care of by the motor nerves. You have a motor response. Eyes, ears, then?
Taste, skin, touch,
yes.
smell.
Yes, nose. And then skin, yes.
Feel.
Yes.
Tongue.
Tongue.
Touch.
Skin is touch. So all your sensory inputs from these sense organs. So the brain takes in the sensory information and the brain will organize this information so that when you see a beautiful flower, you only give a reaction through your words, your speech, or when you smell a beautiful flower, you say, wow, what a nice smell. Instead of, if the signals get confused, you don't eat the flower. So that's the function of the brain, to give the correct response to the stimulus. So it organizes this information with sensory input. Okay? So the brain takes in sensory information, organizes, synthesizes this input, provides instruction for motor output. Whatever relevant reaction has to be given, that will be given through the motor nerves. The brain is the main data center of the body. So not only does it synthesize information, it also stores the memory. So for future you will remember how the flower smelled or how it looked. So that is another function of the brain, memory. And the outermost layer of the brain is called the cerebrum. Think of it as a sheath around your brain. You have seen the brain, no, in pictures, lot of folds. It goes in and out, in and out.
It's like intestine.
It looks like intestine, exactly. So, any reason why it is like that in shape?
It's like walnuts.
It looks like a walnut, very good. Nice. And she's right. Why do you think it is shaped like that?
I think it is to increase the surface area.
Excellent. So I have a few extra, just for your interest, you don't have to learn all this. So 1.5 kg is approximately the weight of the adult brain. So which is actually less than 2% of your body weight. Okay? And the brain is shaped in such a way to accommodate the massive number of neurons. There are so many neurons, it cannot fit into that skull. So that's why it has to fold and go in and out and in and out to accommodate so many neurons. So the folds are called the gyri and the sulci. Okay? So no need to learn, but just G-Y-R-I, gyri. So the gyri are like, your cauliflower, what you were saying, the walnut type. And then the sulci are those depressions and ridges. This is how somewhat your brain is shaped, right? It goes in and out, in and out. So those, when the folds go inwards, they are called sulci. Singular is sulcus. Gyri is also singular gyrus. So that's how this is to accommodate so many neurons. And if you unfold the brain, it occupies 1 square meter approximately.
Okay.
1 square meter. Yeah. And just for information, if you want to impress with your some GK, average 86 billion neurons in the brain. 86 billion. And each neuron forms connections with other neurons. So if you multiply 100 to 500 trillion synapses. A synapse is a point where one neuron connects with another. So 100 to 500 trillion connections in the brain.
So this is in a healthy person's brain, yes? Because someone, for example, is, I don't know, like Alzheimer or it's older, I think it's some difference.
Yes, connections may be the same, but certain areas of the brain become weaker because of memory loss and all that.
So it's
Yes, but what you said is very important. It is important you can keep the connections going by doing various activities. Like if you stop exercising or if you stop playing Sudoku and doing your crosswords, that's why they keep encouraging seniors to do their crossword Sudoku so that the connections in neurons are maintained. And similarly for physical exercise.
So if each neuron is connected to 7,000
Yes.
other layer of neurons, is it stacked?
No, they are not stacked. Of course not. There won't be place if it is just stacked. It's all a big mesh work.
Okay, it's a mesh.
Yes, it is not like your telegraph poles.
Okay, it's not
It's
like
all-
one
no, it's a
neuron,
big-
7.
No,
then-
it is pretty haphazard. Okay, so first of all, the brain itself is not a very regular shape. So it's going to be it's a big tangle of connections, which only the human body can understand.
Yeah. There is an idiom where apparently you can understand the universe before you can understand the human brain.
Fantastic. So just coming to that. So as I said, 100 to 500 trillion synapses are there. Approximately, it's the number of stars in the Milky Way. Okay, so that many connections in the brain. And surface of the brain can be broadly divided into superior surface, then bottom inferior surface close to the neck, then front is called anterior, back of the brain is called posterior. Superior, inferior, anterior and posterior. Yeah, so we were just talking in the brain about the cerebrum, the outermost layer, which we were saying is made up of so many folds. So the outermost layer is called the cerebrum, and the human brain, in the human brain, the cerebrum has evolved in recent times because we think so much, we analyze so much, we use that part of our brain so much, so that part of the brain has evolved a lot. So that again goes to show whichever part of your body you use a lot, that will develop. And that goes the same for the brain also. If you do not use a part of the body, it will go away. If you notice your wisdom tooth, I don't know if you have heard of your wisdom tooth. There is so wisdom tooth actually is called a vestigial organ because it is not really required for chewing. So usually it gets impacted in the mouth and you have to pull it out. Similarly your tonsils and your appendix. So they are called vestigial organs which are not in use anymore and evolution will slowly take it away.
Was there a purpose of them before?
There must be, yes, I'm sure. So just like, we have something called a tailbone. We were supposed to have evolved from a form of primate. So at some point we did have a tail like a monkey. But now because we are not using it, it has become a very short stump. So any part of the body which is not used will through the process of evolution, millions of years it will go away. Same for the brain. Brain is a very good example. The cerebrum is an excellent example of evolution. We have so much of thinking we do nowadays, it has developed very well. Okay? And so the outermost layer is called the cerebrum. And the cerebellum, which is located somewhere at the base of the brain, at the back of the brain, not the base, the back of the brain. I'll show you the picture. It regulates coordination and musculoskeletal functions. So two main parts of the brain are the cerebrum and the cerebellum. उसके बाद brain stem. Okay, I'll show you the picture. Yeah, just come up close now. I'll show you the picture of the brain. So this whole thing is your cerebrum. Okay. Outer layer, cerebrum. And this is at the back or below and behind the cerebrum is your cerebellum. So cerebrum is for analysis, thinking, memory, blah blah blah. And cerebellum is for motor functions, movement, coordination, balance, so that you don't fall down when you are standing or walking. And the third main part of the brain is called your brain stem. So these are the main parts, and this is how you look at the brain if you slice it in half. Now the brain is developed as two parts, okay? Two parts of the cauliflower, or like exactly like a walnut. Walnut has two halves, right? In the middle you can divide it. So this, there is a part, yeah. Now if you cut the brain from top to bottom, that is, it is called the coronal section. Okay? If you make a coronal section of the brain, the center part is called the corpus callosum. This is the corpus callosum. All nerves. All nerves. Easy to answer that question. What is inside the brain? All nerves. And this is another important. I'll send you a picture later on your WhatsApps. This is for the hypothalamus. Hypothalamus, it regulates it gives off many hormones, growth hormone and all that. When you reach puberty and you grow in height, growth hormone, all that is regulated, yes, regulated here. I'm not, pituitary is, where is the pituitary? It's slightly deeper, huh? It is deeper and it is located inside the sac called the sella turcica. Okay, hypothalamus, and then the hypothalamus is the master of the pituitary, if you remember.
So I didn't know they are connected. Hypothalamus.
Pituitary is deeper and it is located in a sac. Okay, and here, actually sorry, this is the thalamus and then this is the hypothalamus. It's a little clearer here. This would be something like this would be the hypothalamus. This is hypothalamus and here would be the hypothalamus. Yeah, and then this is your brain stem. So remember three main parts of the brain: cerebrum, cerebellum, and brain stem. Brain stem further divided into midbrain. Midbrain is located here. So from here starts your brain stem. Midbrain forms, and this long neck-like structure is the medulla oblongata. Medulla oblongata extends into what? Exactly. Extends into the spinal cord. Okay? I'm going to just focus here. Midbrain forms medulla oblongata. Medulla oblongata continues into the spinal cord. Okay? And the whole thing is enclosed in the bony structure called the skull. And the skull you have a big opening here at the back of the neck. That is called your foramen magnum. From the foramen magnum comes the spinal cord. It will pass down to your back.
So, what is the job of medulla oblongata? Is it just
everything? No, everything has a specific function. Just come to that. Yeah. So, medulla oblongata actually is the brain stem, the whole of this structure. The brain stem is deals with heart rate, breathing, digesting food, sleeping, all your involuntary functions. Okay, so you can think logically, it's designed very well. Okay, all your thinking, analysis and all that is here. Your balance and coordination is here in the cerebellum. And your involuntary important functions like heartbeat, digestion and breathing are all in your brain stem. Why in the brain stem and little deeper? So that injury is less. The deeper it is located in your body, the more important it is. If if your breathing functions were located here, and if you get if you get banged on the head, this would get damaged easily, your breathing will stop. It's for that reason that the body has been so beautifully designed that your brain stem is located deeper, so that even if it gets in, it's not so easy to get injured.
So when you say thinking, is it higher order thinking or just normal thinking?
No, not involuntary thinking as in picking up a cup of tea and drinking, not that kind of thinking. No, I am talking about real analysis, character judgment, making decisions, memory, trying to recall some incident or some detail that he has asked you to, in your exams, that kind of thing you need your cerebrum.
Is even language also?
Yes, yes, language also. Logic, language, all that. Yeah. Okay. You can write down functions of brain stem. I'll just dictate it, please write it down quickly. Brain stem. Heart rate, breathing, digesting food, sleeping. And it also plays some role in learning. And cerebrum, the outermost layer of the brain, it accounts for about 2/3 of your brain mass. Okay, and just keep in mind that the brain has been developed as right and left halves joined in the center by the corpus callosum. And like she asked, what is corpus callosum made of? Long neuron branches. That is what it is made of, the corpus callosum.
Memory cells are also inside.
Pardon?
Memory cells.
In the cerebrum? Of course. Memory, yeah, of course. See, memory is an important part of analysis, no? Analysis is important for intelligence. But what you analyze, you base your analysis based on some information that you already know, right? So memory should also be there. Memory is also an important part of your intelligence. So it will be there in your cerebrum.
Is there a difference between long-term memory and
Of course, yeah.
is it stored
Yes.
separately?
Huh?
Is it stored separately?
Yeah, yes, different areas, and that is why you get this Alzheimer's disease.
Yeah.
Short-term memory is affected, right?
Right.
Like what you ate in the morning,
Yeah.
or where you went yesterday. Those are all short-term memories, so that gets affected. But they would remember.
Yes, my grandma, she remembered all lyrics from her primary school, and she didn't remember. So how do you know her name? And her last, she was 96 when she passed. So from her 92, she become like forgetting. Like she asked, and then she don't remember that she asked it. It's just so communication, but she speak all poems which she learned in the school. So it's wow.
See, memory gets affected as we grow older because so much of information we have gathered. I think memory loss is now coming in earlier. I am experiencing some memory losses because every day reading information, somebody gives information here, there, and all that. I think memory. So because the brain can only hold so much, we can only, of course the capacity is immense, but then when there's so much information being overload, there is a tendency to lose some memory also. So that's where yoga and meditation helps, because it cleans the slate. Every day you have to clean the slate so that you get fresh input, fresh ideas. So that's where yoga helps a lot.
And how it is, for example, when they're learning something, and I, for example, like, okay, this is not needful, I don't need to remember this, I need to remember this, and I remember more what I don't need to.
Yeah, it has become important now filtered what you want to learn or what you want to take in. So which is why I don't know, my personal thing is certain forwards you just delete as it is. If the subject is relevant to you and of some interest to you, then you can read it and all that. But then otherwise it just becomes an overload and you will lose some memory.
Yes. It's like that.
And the function of the cerebellum. So, like we saw in that picture, so this is your cerebellum, which is located inferiorly and posteriorly to the cerebrum. So that is involved in your motor functions. Motor functions, coordinated skill movements, dancing, yoga. To some extent, your asana practice requires your cerebellum. Brainstem you wrote, no? Functions of brainstem.
Yes.
Cerebrum you have written, cerebellum you have written. That much would be enough for now. Any idea when the brain and spinal cord formed in your mother's womb? So as early as third week after fertilization, once the the male gamete and the female gamete, the mother's cell, the egg and the sperm, they fertilize, and then your pregnancy test comes positive, and 3 weeks after that, your brain and spinal cord have already. It starts as a tube. It's called the neural tube. Now the neural tube, these are just extra information for your interest. When you go and think over it later, maybe if you become anatomy, go into yoga anatomy, these things will help you. So the neural tube, after some time, it will start developing grooves. And then it will form the brain and the spinal cord. It begins literally as a pipe, as a tube. And it develops grooves, which develops into a top, superior and an inferior, the brain and the spinal cord. So this happens as early, the formation of the neural tube as early as third week after fertilization. Okay? And this so the neural tube, it's like a sheet. And by the end of 4th week of pregnancy, the sheet has closed and formed a tube. So that is called the neural tube closure. And from that is the beginning of your brain, spinal cord, nervous system. Okay?
Is that one of the first organs to form?
Yeah. And then I think, yes, that will be the first one. Then slowly the heartbeat also next. So first will be this one. Okay, now spinal cord is important for carrying messages, incoming messages and outgoing messages. Incoming messages via the sensory nerves, outgoing messages via the motor nerves or the efferent nerves. Okay? And spinal cord acts as a center for reflexes. Reflexes means if you take your hand too close to the fire, you pull your hand away. Or when you go to the doctor's office, in generations ago, he used to do the knee jerk reflex. So he will tap the knee and your leg will lift. So that is called the knee jerk reflex. So all these reflexes are controlled by your spinal cord. Involuntary reflexes.
When they say muscle memory, what do they mean? Like when, especially in sports?
Yes.
Is it somehow related to your reflexes?
Not to reflex, it's related to brain. I can bring that information out and I wrote it down yesterday, muscle memory. I'll get back to it. Peripheral nervous system is the other main division of the nervous system containing all nerves. Now you see all these nerves that are going down, up and down. So those are all the nerves of the peripheral nervous system which lie outside the central nervous system. Primary role of that you can underline, the main role of the PNS is to connect the CNS to the organs, limbs and skin. First of all, because the body is so big and the brain needs to do more important functions. So that's why it delegates to the peripheral nervous system to do all the functions of movement, reflex, etc. Okay. These nerves extend from CNS to the outermost areas of the body, right up to your fingertips and toes, the nerves extend. The PNS allows the brain and spinal cord to receive and send information to other areas of the body which allow us to react to stimuli in our environments. What is the PNS made up of? Many nerves. As we saw earlier, nerve is a bundle of axons of nerve cells. The nerve is a group of the nerve cells which are enclosed in a bundle. They are actually axons or bundles of axons from nerve cells. In some cases the nerves are very small, but big nerves like sciatic nerve you can see with your eye. Some nerves are very small, you cannot see them. Now if you see the next page 57, this is how the sequence is. See the second picture. You bring your finger close to a candle flame or even to the gas burner. Many of us have got burnt, right? All your bombs and all could have got burnt, or you yourself could have got burnt trying or cooking something, right? So you bring your finger close to the flame. This sensation of touch, nerve endings in your finger will send electrical impulses to your spinal cord. So that is the spinal cord there. And from the spinal cord, the motor nerve will send impulses from the spinal cord back to your finger and you will move your finger up. You will jerk your finger. The important thing in this diagram is the direction of the arrows. Okay? So just look at the direction of the arrows, how the sensory receptor goes from the finger to the spinal cord. And it's like a circuit, if you notice. It's like a closed loop. And from the spinal cord, motor nerve going back to your finger. Spinal cord is sending the command to your finger to remove the finger.
Have people studied because it is a impulse that is going to your brain and coming back? Have they noticed if your brain responds slower than your hand?
Yes, in this case not the brain, the spinal cord.
Leg responds slower than your hand because hand is closer to your brain than your hand.
No, that's exactly why. That's why you have so many nerves. So distance doesn't matter. You have nerves which are connected from the legs to your spinal cord and from your arms to the spinal cord at various areas. So distance doesn't matter because the body is so well connected by nerves. So there is no time lapse. It doesn't matter whether it's your arms or your legs. Okay.
About this beat, they say it takes 3 seconds for actually to start burning.
Okay.
But many times, as soon as we go close to flame, we just pull it out even before it starts burning.
Correct.
So why is that happening?
See, there is some conditioning involved there also. Sometimes there are, if you are so used to going to the flame and all that, your response may be slightly delayed. If you are new to the flame and the heat and all that, you will be more sensitive. Now, if I keep roasting papads and chapatis every day, my skin will, first of all, it will become thicker, my nerve endings will become slightly desensitized. It's like how you train the cat to drink milk. Right? So, you give warm milk, first day the cat will run away, then slowly she will start drinking the milk. So, it's how you desensitize your body also. So, if you are new to a task, your reaction time will be less. But if you keep practicing the same thing again and again, your reaction time will be longer.
Also, from your previous experiences, you know that it is going to hurt you. Now your nervous system does not act. Your eyes are also playing a role.
Lot of things, yeah. And the heat may not affect your skin that much also.
Even before your heat is also affecting your eyes, are telling you right there, this is dangerous. You don't do it.
So how these yogi or these people can go to walk on the fire and they not burn it?
Yes, so that is
How's some way this?
that involves, I think, lot of meditative practices. So they bring their mind into a zone where sensory stimuli do not affect them. Now, if you practice yoga for a few years, you will, by few years, you practice yoga here, lot of sounds and activities are going on, but still you are focusing on your posture. So that is it. That kind of focus will reduce your sensory reactions and those stimuli. They do not matter so much because you are so focused on a task. So similarly, the yogi or the fire walker, he must be in a meditative state. He must be focusing on something so sharply that nothing affects him. Maybe he is focusing on Om, or he is focusing on his slow breathing. He must be using a tantric image or whatever, I don't know. Or he is bringing his mind into a transcendental state, slow breathing, all that. So he is desensitized. His reaction time is very long. Long reaction time is good.